Hello, everyone. I'm Chu, a project manager, also serve as the electric energy testing laboratory supervisor, dedicated to the EV charging technology at ITRI's mechanical and mechatronical system research lab. Today, I will show the digital communication conformance test for DC EV charging system. This test is crucial to ensure the charging interoperability between the EVs and the DC EVSEs. It's also one of the necessary tested items for the DC EVSE products certification in Taiwan. Unlike simple charging operations seen in reality, when the EV is charged by a DC EVSE, it operates according to a complex process. It is shown in the figure. The DC EV charging process can be roughly divided into the several phases. If you want to charge an EV, first, you need to plug the EVSE connector into the EV socket. That's the plug-in. And next is the auxiliary low voltage supply. When the EV is successfully connected to the DC EVSE, the DC EVSE will start delivering the 12-volt power to the EV before the starting handshake. Handshake is for EV and the EVSE to confirm that they are connected to each other. After the handshake, the EV and the EVSE will inform each other of their required charging information through the message exchange, such as EV battery parameters and the EVSE performance and so on. EV and the EVSE conform the compatibility at the charging parameter setting phase. This means EVSE is confirmed to support the EV charging, and the EV can use EVSE to charge. In the charging phase, the DC EVSE starts to transfer the energy to EV. Both the EV and the DC EVSE send and receive the message constantly. In the charging stop phase, the DC EVSE stopped to transfer the energy to the EV and terminate the charging section. In DC charging mode, due to more safety consideration and more complex power control requirement, EV and the DC EVSE should exchange messaging by applying the digital communication. For each of the charging phases, we have described previously. The related standards or the regulations define the request and the response message with different names used in EV and the DC EVSE. Each message contains multiple parameters or the element value. So how to execute the communication conformance test? In short, the DC charging process is simulated through the automatic testing system, and the various test cases are executed at different phases to verify the digital communication compliance of the EV and or DC EVSE. The test system consists of one EVCC emulator, one SECC emulator, and the other electric power and the major equipment. If the device under test is an EV, the system will stop the SECC emulator. Otherwise, to test the DC EVSE, stop the EVCC emulator. The test cases are designed different depending on whether the device under test is an EV or the DC EVSE. So the next question is, how are the test cases developed? Let's take a combined charging system as an example. First, there are three necessary conditions for constituting a charging communication section between an EVSE during the charge: CP voltage, timing, and the message. CP voltage is used to control the progress of the charging phase or the steps. After completing the plug-in, CP voltage is 12 volt. Then it changes to 9 volt and stops to handshake and the subsequent step. When the CP voltage switches to the 6 volt, start the steps corresponding higher voltage power transmission. The second condition is timing. Each state or phase must be completed within a specified time, and both the EV sending the request message and the EVSE send the response message must be complete within a time limit. Finally, the messages sent by the EV and the DC EVSE must be correct, including the message name and the element value within the message. Generally speaking, the test case involves adjusting the three conditions: CP voltage, timing, and the message. Intentionally input the incorrect element value or the error message to verify whether the EV or the DC EVSE has compliance countermeasures. Currently, there are the three types of DC charging system in the IEC standard. The System A, same as the CHAdeMO, this is the system development by the Japan. And System B, that's the GB, proposed by the China. System C, this is what we call the Combined Charging System, or the CCS, jointly proposed by the US and the EU. The IEC, the 61 and the 51-24 standard does not provide a detailed explanation of the digital communication for the three DC charging system. The technical detail of each charging system's requirement and the test case need to be referred to other standards under the specification. For example, if you want to understand the details of digital communication for System C, you must consult the DIN regulation or the ISO standards. The digital communication conformance test is one of the voluntary product certification mandatory items for the DC EVSE product in Taiwan now, and it will be a mandatory item for the registration for the product certification next year. Electrical Energy Testing Laboratory under the Mechanical and the Mechatronical System Research Labs is one of the BSMI designated testing laboratory for the verifying the DC EVSE digital communication conformance. The laboratory has assisted many the Taiwanese manufacturers in completing testing and the verification of the DC EVSE and the EV products, including the Delta Electronic, ITRI Go, China Motor Cooperation, and so on. We look forward to collaborate with not domestic manufacturing and believe that we can provide a huge assistance in the development of the DC charging system digital communication technology.